Hey guys, Mr. Gucci here, and this is a homework help video for the 14.3 worksheet, pH and pOH. I'm going to break this up into two videos, one where I solve problems numbers 1 through 9, the odds, all right, these guys here, and the second video where I'm going to solve this Mamba Jahamba down here. So if you're just here for this Mamba Jahamba, skip, go to the next video. All right, let's work on this now. So what is pH and pOH? Well, pH is the concentration, the power of an acid in a solution, and it's a simple scale. It's a 0 to 14 scale, and if you are acidic, you're on the low end of the scale. If you're basic, you're on the high end of the scale. All right. Remember, the joke that we use is that your mom must be a 10 on the pH scale because she's basic. Use that and credit Mr. Gucci, all right? Here are some everyday substances and where they fall on the pH scale. Stomach acid and cola are on the low end. They're very acidic. They're very tart, all right? If you've ever thrown up, you know stomach acid is pretty tart, all right? Cola, slightly less tart. Banana, tart less still. Water, smack in the middle, is neither an acid nor a base. It is neutral. All right, and then over here on the basic side, we got your blood, we got baking soda, and ammonia all the way on the far end over here, okay? And so the way that we find out how acidic or basic something is we take the pH. The pH, the power of hydrogen, how acidic something is equal to the negative log of whatever the concentration of the acid is. Now, you might be like, Mr. Gucci, what the heck is log? All right, listen, here's a little brief lesson on what log is, all right? The log function, which many of you have learned in algebra this year, and from my general polling, none of you like, the log function tells us how many times you must bounce a decimal to get 1. All right. So let's take an example. All right. So for example, let's say you got 0.00001. All right. In order to get 1, you must bounce the decimal 1, 2, 3, 4, 5 places. All right. 5 places. So in this case, the log of this number would be -5, because you have to bounce the decimal place 5 spots to the left, to the small side. All right. On the other hand, what is the log of 1 million? All right. What is the log of 1 million? Well, you'd have to get 1. You'd have to bounce the decimal 1, 2, 3, 4, 5, 6. All right. So the log of a million is equal to 6. But the wild thing about logs is that you could also do the logs of more complicated numbers. What is the log, for example, of, let's see here, 256,000. All right. How many times would you have to bounce the decimal place in order to get it to be equal to 1? Well, 1, 2, 3, 4. If you bounce it 5 times, you have 2.56, which is more than 1. If you bounce it 6 times, you have 0.256, which is less than 1. So the log of this value right here is some number between 5 and 6, because you'd have to bounce the decimal someplace between, somewhere between 5 and 6 times. Okay, now this is just Mr. Gucci's help visualizing logs. Okay, so we're going to use this now, and we are going to calculate the pH of various acids and bases. All right, so let's take a look at this worksheet. I'm doing the odds on this worksheet. So, oops. Find yourself, Mr. Gucci. Jesus. There we go. Boom, boom. All right, so here we go. So, what is the pH of a 0.01 molar solution of hydrochloric acid? This is an acid, so we can find the pH from it. Let's figure out. Well, first of all, just looking at this, let's see here. So we want to take, in order to find the pH, that is equal to the negative log of the concentration of the acid, 0.01. All right. So we could just plug this into our calculator or plug this into Google. Negative log of 0.01 is going to equal 2. All right, 2. There we go. All right, so this has a pH of 2. And again, when we remember that log is just how many times you have to bounce the decimal point to get it to equal 1, we would bounce the decimal point over one place and then two places, and that would get us 1 exactly. So the pH of this thing is 2. Is it acidic or basic? Well, remember, the pH scale, 7 is the middle. If you're on the lower side, if you're lower than 7, you're acidic. If you're greater than 7, you're basic. Remember, yo mama is a 10 on the pH scale because she basic. All right, so this right here is acidic. The pH is less than 7. Boom, acid. All right, let's take a look at number 3. What is the pH of a solution that is 5.6 times 10 to the negative 6 molar nitric acid? So again, we're taking the pH is going to equal the negative log of 5.6 times 10 to the negative 6th. All right, let me just get there we go, cool. Now this number right here, by the way, this is in scientific notation, all right? But it could also be 0.000056. Remember, log is just how many times do you have to bounce the decimal to get this number to equal 1? All right, well, if we bounce it 1, 2, 3, 4, 5 times, we get 0.56, which is less than 1. But if we bounce it 6 times, we get 5.6, which is more than 1. So we're bouncing this somewhere between 5 and 6 times. So I'm betting that the pH of this thing is 5 point something, somewhere between 5 and 6. And let's just do this. Let's just plug this into Google. What is the negative log? 5.25. Very good. So that's the pH of this, 5.25. And it's acidic, all right, because it's still less than 7. All right, it's not as acidic as the answer number 1, but it's still acidic. All right. Now, again, if everything I've been saying about what log means is just going in one ear and out the other, then as far as you're concerned, this is a magical series of buttons that you push on your calculator, and doing so will get you the right answer. Trust me, that mentality has gotten more than its fair share of students through chemistry. All right. Now, again, pH. You could even enter in the scientific notation form, and it'll still work out. All right, the negative log of 5.6 times 10 raised to the negative 6. Google smart. If I were to just copy this and slap this into Google, boom, exact same thing. So however you want to write it or plug it into your calculator, Google knows. Google always knows. All right. Anyways, that's that. Let's move on to these problems down here. All right. pH and pOH. Oh wait, what the heck is pOH, Mr. Gucci? Well, listen. pOH is the opposite of pH. If pH is how strong of an acid it is, pOH is how strong of a base it is. All right. And the way these solutions work is they are either acids or bases. You can be one or the other. You cannot be both a strong acid and a strong base. If you mix a strong acid and base together, they will cancel out and one of them will likely win. If there's a little acid left over, it's acidic. If there's a little base left over, it's a base. It is similar to the charges of ions. An ion cannot be both positive and negative. It's one or the other. You put a bunch of protons and electrons together with opposite charges, you're not going to get something that's positive and negative. Those charges are going to cancel out and leave you with one or the other. And it's the same with acids and bases. If you have a lot of acid and add base, it'll cancel it out until it's slightly less acidic or even becomes basic. It's one or the other. And because it's a 0 to 14 scale, the power of the acid plus the power of the base always equals 14. All right. So what I know is however powerful the acid is plus however powerful of a base it is, it always equals 14. So if I know that the power of the base, the pOH, is 4.5, and I want to figure out what's the pH, well, the pH plus the pOH has got to equal 14. So 4.5 plus what equals 14? What I'm going to do is I'm just going to do 14 minus 4.5. And what I get is 9.5. That is the pH. The pH equals 9.5. Now, is that acidic or is it basic? All right. If the pH is greater than 7, it's basic. If it's less than 7, it's acidic. Remember, if your mama's a 10 on the pH scale, it's because she's basic. All right. It's greater than 7, so this is a basic solution. Basic. All right. Basic. All right. Let's take a look at number 7. What is the pH of a solution that has a pOH of 13.2? So if the power of the base is 13.2, what is its power rating as an acid? Well, pH plus 13.2 equals 14. A little bit of subtraction here. 14 minus 13.2 equals 0.8. The pH of this thing is 0.8. This is acidic, very acidic. It's very, very low on the pH scale. This is like the acidity of your stomach acid, all right? That can dissolve, animal matter, plant matter. Right? It can dissolve organic matter. Gross, all right? So there you go. That's very, very acidic. All right. Now, last question down here is, what is the pH of a solution of 0.00067 molar sodium hydroxide? Okay, now listen, your instinct might be like, oh, Mr. Gucci, I'm just going to take the negative log of 0.00067, and that's going to tell me how powerful this solution is. All right, remember, log is how many times you have to bounce the decimal to get it to equal 1. Well, you bounce it once, you bounce it twice, you bounce it 3 times, and you're a bit less than 1. Bounce it 4 times, and you're a bit more than 1. So the pH I know is going to be 3 point something. Let me put this into the Googles. Boom. It'll be 3 point something. I can feel it. 3.17. All right. So this is going to be 3.17. Here's a problem. Here's a problem, guys. The problem is you took the negative log not of the concentration of the acid. You took the negative log of a base. This is the negative log of a base. All right. And the negative log of a base gives you not the pH, but the pOH. So what we just found here was not the pH. Because this substance is a base, we found the pOH. Okay? So if we want to find the pH, we got to go one extra step. Remember, pH plus pOH equals 14. So the pH plus 3.17 equals 14. 14 minus 3.17 equals, mental math, 10.83. All right, 10.83. The pH equals 10.83. And it's 10, so it's basic, like your mama. All right, I'm being discriminatory. Your dad could also be a 10. All right, your father could also be. Any of your parents. Guys, listen, it's 2022. Anyone can be basic. All right, this is the world we live in. All right, get with the program. So there we go, guys. These are the odd problems on this worksheet. Okay, for the first ones up here, the easy ones, I'm giving you the concentration of the acid. So just take the negative log, and that's the pH. Okay, on these problems, I'm giving you the pOH, and I'm asking you to find the pH, all right? The power of the base, the pOH, plus the power of an acid. always equals 14 because they're opposite sides of the same scale. So if you know the pOH, subtract it from 14 and you get the pH. All right. And lastly, if I give you the concentration of a base, taking the negative log will give you the pOH, and then you got to subtract it from 14 in order to get the pH. Remember, if it's less than 7, it's acidic. And if it's more than 7, it's basic. All right. Hey, did you know you're a 10 on the pH scale because you're basic? There you go, guys. That's part 1. I'm going to make part 2 right now later.